This lesson, we're going to talk about inequalities, but graphing them on a coordinate plane. You already learned how to graph inequalities on a number line. This is going to take it a step further because these inequalities are going to have x and y values, or two variables, as opposed to those with the number line that had one variable. So let's look at the steps. First step is to solve for y. After that, you're going to try to determine whether or not you will be drawing a solid line or a dashed line. Solid line is going to be for less than or equal to's or greater than or equal to's. Whereas a dashed line will be when there's a less than or greater than sign in the problem without the equal to. It's going to be a similar concept to the open and closed circle. So the solid line indicates the equal to, whereas the dotted is without the equal to. Then you're going to draw the line on the coordinate plane, and then we got to talk about shading. Here's a little bit about the shading. If it's a greater than sign, you're going to shade above the line. And if there's a less than sign in the problem, we're going to shade below the line. So we'll take a look at that. Here's our first example. Y is less than or equal to 2x minus 1. Well, the first step is already done. Very nice. It's already solved for y. So we have y is less than or equal to 2x minus 1. Decision to be made is what kind of line to draw, and because of the equal to, we're going to draw a solid line and then draw the line. So we're going to go back to your knowledge of slope-intercept form. It has a y-intercept of -1, so we graph that point, and then we will go up to and over 1 for our slope, and there we draw the line and make it solid because of the equal sign. Now we have to talk about the shading. It's a less than sign. If it's less than, we're going to shade below the line. So in this case, it's to the right of the line. And this blue here indicates shading. So that's the first example that I wanted to show you with drawing the line and then with the shading. This example, -4x plus 2y is less than 6, is going to require us to solve for y. So again, going back to your equation solving, we can apply that as well to the inequalities. And with that, you will solve to find y is less than 3 plus 2x. Again, in slope-intercept form. We're going to use a dashed line because of the less than sign. So there's our dashed line. And draw the line with a y-intercept of 3 and a slope of 2. A less than is going to be below the line. So all the shading goes below the line. Now the meaning of the shading is to indicate that all these ordered pairs where the shading is would solve this inequality. So for example, 1, 1, 4, 2, all these numbers, 1, -2, all those ordered pairs would be solutions for this problem. So it's a visual representation of all the solutions for that inequality. Here's another example I selected. 4 minus 2y is less than 6x. Again, solving for y. I chose this because you're going to have to divide by -2 while you're solving for y. And if you recall from the inequalities on graphing, with the number line, anytime you divide by a negative, we have to reverse this sign. So again, I wanted to point that out. Here you have a less than, you divide by -2, so we need to make that a greater than sign. Reversed it. So here we have a y-intercept of 2, right there, and a slope of -3. So we could go down 3 and over 1 and graph that line. Dotted line or dashed line because of the less than sign or greater than sign. And then we're going to shade, because it's a greater than, above the line. So there's our shading to the right or above the line on this one. Let's look at this example. Similar, lots of things going on that are the same. We're going to solve for y. We're going to decide it's a dotted line. We're going to draw the line. I want to talk about the shading, though. You may have had some questions about, well, what do you mean by above? What do you mean by below? Some lines it's going to be very clear. If the line is relatively flat, with a slope like this or just the other direction, it's going to be fairly clear. But on something that becomes a steeper slope, we're not quite sure, well, what's above and below? So there's another way to do this. We can test a point. All right, so let's go back. We solve for y, decide on a dotted line, draw the line. Now let's talk that shading. Rather than try above, below, let's test a point. I chose a point on either side of the line. I chose 0, 0. Simple numbers to work with, and it is not on the line or very close to the line. What I'd like to do with 0, 0 is put it into the original equation, or inequality. So we have 8x plus 4y is less than 8. If I put in a 0 for x and a 0 for y, you're going to see that 0 is less than 8. Is that true? Well, yes, it is. Well, that's an indication, if it's true, that that's a solution. And if that's a solution, then that's the side that should be shaded. So then I would shade this side of the line, because that's the side that included 0, 0 as our testing point. If we had tested a point in this area, it would not have come out true, so we would not shade it. I wanted to talk about these two situations to refresh your memory, and then how to graph these. Graphing inequalities, but let's look at this first one. Y is less than or equal to 3. Well, if you recall, that's one of our Hague problems. Y equals a horizontal line. So I drew a horizontal line through 3. And it's solid because of the equal sign. Well, let's think about the shading. If y is less than or equal to 3, where are the y values less than 3? Well, with this being the y-axis, your y values less than 3 are 2, 1, 0 negatives. So your shading for this problem would be here. And it's below the line because it's a less than. However, let's look at this problem. This inequality is x is greater than negative 2. That's of x. X equals is a vertical line. So I drew a vertical line through negative 2, and it's dotted because there's no equal sign. Now we have to decide on shading. Well, this is obviously not above or below, so we need to think on this situation. Where are the x's greater than negative 2? Well, if you think about that, here's your x-axis. Here's negative 1, 0, 1, 2, 3. Those are greater than negative 2, so I would shade here. And that would be our shading for that problem. So that gives you a look at horizontal and vertical lines, as well as the lines that have a variety of slopes.